So, missing data. The first thing we have to wonder ourselves is, when do we have missing data? So many times we're going to see that in a table we don't have the number or the label, the class, whatever it is, fine. But some other times there are specific values or ranges of values that also mean missing data. For instance, there are many times in which a numerical variable equals 0 means there's no value, or negative, that means there's no value, or the empty string, that means there's no value. So first thing to know and to get a really good understanding of where the data comes from is, when is it that is signaling us that there's no data, that there's data missing. And then you have to start questioning, are they expected? So maybe in some cases we see that whenever some variable equals 0, then we should not have a corresponding value for another variable, things like that. So if we have a missing value, does that mean that the other one is 0? Can we check that and make sure that things are okay? That's something we should always do when we see missing data. Try to see whether it's actually correct that it's missing. And why are they missing? So means something specific. Maybe they respond to a certain pattern, like, hey, every time we have missing data in here, it's actually because this sensor just went crazy and it didn't give us any reading, for example. So instead of giving us a reading that was very much incorrect, it just didn't give us anything. So those are things that might be telling us something useful about the phenomena that we are looking the data about. And then we have to decide, what do we want to do with them? So something that we could do is just remove the entire observation. So all the variables that pertain to the same observation in which we observe this missing value, we just remove it. All variables. We don't care about this observation whatsoever. It might be too harsh, right? Maybe we have valuable information in these other variables. Something that we could do is just ignore the observation in that specific variable, but still keep the values that we have for the other variables. Maybe those are still useful, right? Just because we have a missing value in one variable doesn't mean that the other variables are useless for that same observation. Maybe what we could do is just replace that missing value with the average of the whole variable and keep on going, knowing that, we are doing something in there. We are reducing the variability in the dataset, for example, but it might allow us to just move on. It might be a reasonable assumption, and it's not hurting the rest of the analysis, for example. So another thing to look into are typical values or atypical values. And we have to look for places where there are many or just a few observations and start wondering again, are they expected? Is it expected that we have so many observations around this range of data, or that we have just a few observations in here and in there when we perhaps should have more? What do they mean? Maybe again, they respond to a pattern. So if we have listings with a price over 2,000 euros, those are suspicious. Those are maybe, phony places. We don't know. Maybe they were just errors in the data. Maybe, again, a sensor just went crazy or someone made a mistake entering the numbers into the computer. Those could happen. It's just a good thing to look into the ranges of data, outliers, etc., to make sure that there's nothing funny going on. And if they're outliers, should we remove them? Should we ignore them? Should we just use them to, for example, see what an overall distribution looks like, but all the time just plot specific portions of the variable where the bulk of the data are? Those are decisions we have to make about. And then something important is that if we see many observations, for example, scattered through, a scatter plot, that might mean there is an effect of a third variable. There is something that we are not accounting for, and it might be responsible for this clustering of the data in different places of the scatter plot. So what is it about the observations that are close together? What is it about the observations that are far apart? Do they maybe correspond to a certain pattern, certain characteristic that makes sense and is allowing us to go one step farther into gaining new insights? So these are questions that lead to exploring relationships between the variables. So we might hypothesize that there is this other variable that is responsible for this organization of the observations in scatter plot. Then we go into that direction and start looking for new relationships or patterns that might be able to explain what we are seeing in the data. We're going to see how to do that later when we talk about more than two variables at the same time. But let's see. So here on the left, we have a histogram of the diamond carats. And we have a beam size very, 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 very small. And so what we see is that there seem to be more observations slightly to the right of the peaks. So what we saw is that, yeah, there are peaks at, for example, 2 carats, and 1.5, 175, 1.25, 1, etc., etc. But there's especially a lot of observations towards the right of those points, right? So, for example, we see this shape. There's not any observation towards the left. There are observations towards the right. And that has a very clear explanation in this case. And that is that once someone gets a raw diamond and they have to start cutting it, what they're going to ensure is a minimum carat, which is just the weight of the diamond. So they're going to make a design such that the carat of the diamond is at least 2 carats or 1.5 carats. And then from there, they just shape the diamond however they want, at least meeting 2 carats. Why? Because people are going to pay you a lot more if you have at least 2 carats. Once you are over the 2 carats, then you don't care if it's 2 and a little bit. So this is something that might be useful to know, and we are uncovering this new knowledge just by looking into the histogram. Here on the right, we have the geographical distribution of the listings in Berlin, and what we're doing is use the color to display the price. And what we see here is immediately that there are some listings below 10 euros, this very light green, and there are some listings above 1,000 euros. That's weird, right? So in general, we see the prices look reasonable, yeah, but a lot of red, a lot of green. And what if those listings belong to the same person? Or those listings have a certain commonality that it's always the same people who rent those places? That might be informative. That might be telling us something. And again, this is a relationship that we can only see by plotting the data.